And I want to thank all the, I'll start over. Hi, John, thanks so much for the introduction. And I want to thank the governor's office and Innovate US for their partnership in doing this. And I want to thank all the participants. We have over 200 people logged in right now. And this is the first of what we hope to be many sessions focused specifically on responsible AI for public safety. This session is titled AI Fundamentals for Public Safety, which we're going to get into um, um, in just a moment. This is a foundational entry point. So I want to be clear. So this is not a technical course. We will be diving into more of the concepts and things that I'll be covering today in greater detail in subsequent sessions. So encourage you to log on to Innovate US and take a look at those sessions and take a look at the titles. We have a great lineup of speakers that are going to be diving, as I said, more deeply into those topics. But this one is a fundamental session. We're not going to be, it's not about math. We're not going to be doing any coding, talking about anything like that, thank goodness. But we're going to be talking about artificial intelligence and public safety. So as we all know, AI has been in the news, and AI is very much ingrained in public safety. And this course will help leaders. We're hoping it will help you all to understand it, to decide what to use and what not to use, the right tool for the right job, and also for responsible and informed implementation into your agencies. We're hopefully going to lay some groundwork for some more advanced policy discussions later on. So just to go over, if you can all see my screen. So the roadmap for today. Today, we're going to cover the core concepts of artificial intelligence, specifically generative AI, machine learning, predictive analytics. Now, these are not all encompassing. There are many other forms, agentic neural networks, things that are a little bit more detailed that we won't be touching on today, but we will later on in later sessions. So these are really the foundational points of artificial intelligence, and then the applications of them in policing and public safety. And we'll also cover some risk, benefits, ethics, and governance in applications and in implementing these things, these tools into public safety. And as I said, there's no coding background needed for this session. This is a focus on concepts and not math. So just to start out, again, with the basics, what is artificial intelligence? So by definition, artificial intelligence refers to computer systems that are programmed and designed to perform tasks that typically require human intelligence. That includes decision-making, language understanding, visual perception, pattern recognition, all of these things. And AI does not think like humans, but it uses logic, data, algorithms to replicate certain cognitive functions. This will change as more and more advanced models become available. And even recently, there's been some advertisement of certain models from Georgia Tech that have recently been published about how much closer it is getting to actually thinking. And some examples of this, we have language understanding, multiple language understanding, that where computers can understand the spoken word, decision-making capabilities, pattern recognitions. And as I said, AI doesn't think yet, but it finds patterns in this data, and it makes predictions based on that large amount of data, and provides outcomes, and et cetera. Some everyday examples that you may be familiar with. If anyone watches Netflix, the recommendations that come up on your profile in Netflix, those are driven by AI. Your GPS, your navigation system on your phone or on your car. Sometimes they'll use AI for rerouting you to better, more expedient routes. Spam filters on emails and phones. These are other things that are driven by AI. Some of the core vocabulary we're going to be covering today: algorithm, which is a set of rules for a task, calculations, data sets. Data set or a corpus of data is information that the AI learns from. A model is what we refer to as a trained system that makes predictions and different models for different purposes. Training versus inference. So training is teaching the AI or it's learning versus applying AI for getting an outcome. And certain examples of that would be AI training on data burglary data. That's a tongue twister, where it trains and then it predicts particular hotspots based on maybe geography or time of day, and that is the inference. Machine learning, that's the first core concept we're going to be talking about. Machine learning is a subset of artificial intelligence that focuses on enabling systems to learn from data and improve their performance over time without explicitly being programmed for every possible outcome, right? So machine learning powers most modern AI tools by using large data sets or large corpuses of data. They identify patterns, and from those patterns, they can make predictions. Um, there's supervised learning, which is a system that is trained with labeled examples. Labeled examples, in other words, are images that are labeled or tagged as a weapon, a car, or any other item, or tagged with non-weapon or not a car. And the system will learn based on those tags. And then you have unsupervised learning. This is a system that provides patterns in unlabeled data. So clustering theft reports, for instance. License plate reader is a great example of that, which would, that are trained to detect, scan the license plate and detect by matching it to a database or a list of known stolen vehicles with that license plate, and then it can make the correlation and then make an alert. Some other real world examples, and throughout this presentation, I'm going to try to tie this back to some real world examples of artificial intelligence that is implemented currently, and also looking forward. So some real world examples of artificial intelligence and machine learning in law enforcement. We have facial recognition systems. And these, I know a lot of people on this call have probably heard about them before, but these are systems that are trained on image databases that they match or identify suspects from surveillance footage, CCTV cameras, body-worn cameras that police wear. LPRs, or license plate readers, uses machine learning to scan plates and detect matches, as I mentioned, to lists of stolen vehicle databases. Predictive policing. This is something that we're going to get into more detail, all of these into more detail later on. But machine learning algorithms will analyze crime data to identify high-risk areas to forecast future incidents, right? So it looks at historical data, time of day, geographic location, and then it takes into account what may happen at a future day and time. It also takes into account recidivism. Recidivism is the likelihood of a criminal to be a repeat offender. So it takes that information and then identifies either individuals or locations to say this area or individual may be a higher chance of them committing the same or another act, a criminal act. 911 call classification. This is an interesting one. So NLP, which are natural language processing, which transcribes categories, which transcribes and categorizes emergency calls to improve dispatch decisions. So 911 call center is being overwhelmed by a myriad of calls. This will triage those calls and then direct them to filter out the emergent and non-emergent calls so it gets answered by a human being. The higher level ones and the higher risk ones certainly getting put to a 911 call receiver. Gunshot detection systems are another thing that you may or may not have heard of. These are acoustic sensors that are AI enabled that are positioned throughout an area, normally in an urban area, where they identify if someone fires a weapon. These sensors can triangulate and locate almost immediately where that shot was fired, the location of the shooter, and then take that information and filter it up to a real-time crime center or to a fusion center at police to let them know, and to let local police know in the area. So understanding some other things about supervised and unsupervised learning. So supervised learning is, as I mentioned, talk about where the system is trained on labeled data. An example of that is an AI model trained to recognize the shape of a gun in an X-ray by showing it thousands and thousands of guns, pictures and scans of guns that are labeled gun. And some of these have become so proficient that they can even determine what type of gun it is, the caliber of the weapon, even in certain instances. And unsupervised learning is where it's given unlabeled data, as we mentioned. So an example of this is the analysis of databases of theft reports without knowing what caused them, but the algorithm groups similar incidents to reveal patterns, right? Or do we have thefts? Are they violent crime, nonviolent crime, carjackings, car thefts, things like that? But the one thing I'd like to reinforce though is that AI is only as good as the data and assumptions behind it. So the old adage, bad data in, bad data out, is never more true than in artificial intelligence. And we'll get into that in a little bit more. So predictive policing, predictive analytics, actually. Um, so really, the core definition of predictive analytics is it uses historical data to forecast likely future events. So in public safety, this often means predicting crime locations, the times, risk levels, like how severe they are, based on past records. Um, and how this works is it collects the data through crime reports, arrest logs, calls for service, time and location data. It feeds this data into an AI or machine learning model, and then the system identifies patterns. For instance, like thefts spike on Friday nights near a shopping mall. So then the output of that could be a hotspot map or a risk score for specific areas, for individuals or timeframes. And this goes into informing precision policing, and we'll get into that in a little bit. Some examples of this: hotspot policing. LAPD a number of years ago implemented something called PredPol, PREDPOL, which is, I'm assuming it's predictive policing, which used algorithms to suggest patrol areas where thefts and burglaries were likely to take place, and it focused policing efforts in those areas. Risk assessment in the UK, the Kent police used predictive tools to flag individuals with a higher likelihood of reoffending or recidivist, and 911 data analysis. There are some agencies, which I'll mention later, that use predictive models to anticipate peak times of certain calls, whether it's traffic collisions, overdoses, or calls for service to collect a cat out of a tree. Some of the benefits of these technologies, with some of the obvious ones: it helps allocate limited resources, and police at this point in time, with the recruitment and retention challenges that they have, there are always resources that are limited. It helps allocate those limited resources more efficiently. It may prevent crime by increasing visibility in forecasted hotspots, so targeted policing and targeted in areas. It supports proactive policing rather than purely reactive policing. So we're mitigating it before the crimes can even take place in certain cases. Some of the limitations and risks, because with any implementation of an AI model, any new technology, there are some limitations, there are some risks, inherent risks. Biased data means biased predictions. So if past data reflects the disproportionate enforcement in a certain area or in certain communities, that model will keep predicting that crime in that area, reinforcing cycles of potential over-policing. You have the potential for false positives, where flagging areas or people incorrectly will waste resources. It'll erode trust from the community. And then there's also transparency challenges after implementation. And this is something that leaders must be able to explain to their officers and communities why a neighborhood was flagged for an increased police presence. So, and here's a question that just for all of you to think about. But if predictive analytics flagged one neighborhood repeatedly for a high risk activity, how would your community perceive that? And what safeguards would you want in place if they were incorrect in that assumption? So next slide we get into is generative AI. It's a little bit different, a little more advanced. Generative AI creates new content, whether it's text, images, video. In public safety, generative AI is being used to draft initial police reports based on initial input from the officers, creating training scenarios, summarizing large volumes of case data. I'm sure if anyone's on Instagram or any of the, TikTok or Instagram, they see a myriad of artificial intelligence generated videos that are, I find most of them comical, but they can be used in training scenarios for more realistic, very realistic training scenarios. One of the cautions with this, though, is that the AI can hallucinate or generate false information. So everything that comes out of these in any model, for that instance, must be verified, and keeping humans in the loop. Get into that a little bit further later and in the next session. But generative artificial intelligence, which is Gen AI or generative AI, it refers to systems that create new content, as I mentioned. So these are in the public safety, they use these tools they're being piloted to automate police report writing. You can imagine the benefits of that and streamlining and having police out enforcing the law versus writing reports, which consumes a lot of time and a lot of the officer's time. And early peer-reviewed studies highlight how Gen AI can draft initial versions of reports, though users, of course, must verify carefully for accuracy. Some advantages and considerations. Obviously, we have efficiency gains, creative amplification, which means that generative models can expand possibilities for training situations, scenario planning, or victim statement drafting. And the risks to monitor, as I mentioned, the hallucinations, the data bias, also ownership and attribution. And these are questions that arise around provenance, especially for legal documentation. Who owns AI generated text? Who is liable if it is incorrect? So getting into some of the key differences between these, we have machine learning, predictive analytics, generative AI. So the core purpose for machine learning is it learns from data to classify or predict. It's trained on labeled or unlabeled data to recognize patterns. And one of the examples are license plate readers identifying stolen vehicles. Predictive analytics forecasts likely future outcomes. It uses historical data and statistical machine learning models to project trends. And I mentioned the crime hotspot maps or burglary or theft. Generative AI creates new content. It uses deep learning models like transformers or GANs, which is generative and adversarial network, to generate outputs based on the training. And this is being used to draft initial incident reports or creating substantive training, lifelike training. But think of machine learning as pattern recognition. And in public safety, it's already being used. Body cam analysis, detecting weapons, automatic license plate recognition. It doesn't create new data. It classifies or predicts based on what it's seen before. So it uses historical data and makes determination from there. Predictive analytics is more about forecasting the future based on trends in the past. And this is a valuable resource allocation, but carries the risk of reinforcing historical biases, as I mentioned. And generative, as I mentioned, the biggest difference is that it creates, okay? It uses models like ChatGPT to draft reports, generate summaries, or even simulates crime scenarios for training. It is an exciting potential, but requires caution. It can produce inaccurate or fabricated details or hallucinations, which is why, in all instances, this needs human verification before use in official records or decision-making. So to get into some real-world applications that we talked about, facial recognition for suspect identification uses AI algorithms to compare facial images from surveillance footage, from body-worn cameras, mobile devices, and compares them against criminal databases, mugshot repositories, license plate or DMV records. Natural language processing analyzes 911 calls, to transcribe, to analyze, categorize 911 calls in real time to detect priority issues or to escalate urgent cases. Now, the return on this investment in implementing this is that it triages non-emergency calls to the appropriate departments, so humans can address the real emergencies. Gunshot detection systems, as I mentioned before, it sends alerts automatically to once it's heard a gunshot, it sends alerts to dispatchers in crime centers and patrols nearby to immediately respond. And the return on investment in that is faster response to shootings, which has the potential to save lives and improve clearance rates of unsolved crimes. Crime pattern detection using surveillance video. This process uses neural networks, which is another form of AI, but these are algorithms modeled loosely after the human brain used in deep learning which allows computers to automatically discover relationships in data. It identifies patterns in large criminal data sets, behavioral analysis from surveillance video, automated classification of incidents or threats. Some of the examples of this, NYPD has facial recognition, and they use it to match suspects from CCTV video or mugshots to databases. Um, Natural language processing, or NLP, systems handle the non-emergency 911 calls. This is already deployed in over a dozen dispatch centers since May of 2024, including in Snohomish County, Washington, and um, Chattanooga, Tennessee. And this system helps free human dispatchers to focus on true emergencies. And they've also been tested for triaging non-emergency calls in Toronto. So the benefits of AI in public safety. AI accelerates investigations. It reduces manual work, which is an improvement and making things more efficiency. It can process massive volumes of information faster, more accurately than humans can, which helps agencies reduce time to lead, closes cases more efficiently, reallocates human resources to strategic work. We have digital evidence sorting, for instance, automatically categorizes data from cell phones, body cams, laptops. It sorts texts, images, and files using keyword filters, image recognition. So if a suspect is arrested, they'll obtain their cell phone and they can plop it into certain technologies, which will download everything and then automatically categorize them based on whether they're text, images, files, keywords, phone calls, things of that nature, to help detectives spend less time on data entry and more time on, uh, uh, um, um, you know, inspecting and looking for correlations. Some other safety or officer safety examples. So we have LPRs, gunshot detection, real-time crime centers, which or RTCCs, which there are a number of them around the country. They aggregate data from a myriad of different sources: drones, social media, license plate readers, CCTV cameras. They can detect emerging threats based on the information that's obtained. Street racing, flash mobs, armed gatherings. If a protest, it could be analyzed. Protests can be analyzed to see if it's going to transition into a potential riot where violence may occur. It can analyze this. It can determine using AI the tenor of the crowd to see if they are getting more than just a peaceful protest. Um, AI is being used to protect officers while on the road performing traffic stops or en route, going code 3, which means their lights on in an emergent event. And the way that's used is the AI is it identifies the location of the officer when they have their lights on, and it starts sending alerts to the motoring public, the surrounding motoring public who may be using their GPS on their phone or their GPS on their car, and it makes them aware if an officer is performing a traffic stop on the side of a highway. It makes them aware when the police are on the scene of an accident. It operationalizes the slow down and move over laws that all 50 states have, but we unfortunately we rarely see that out on the roads today. It's also being used to predict when the officers or any emergency response vehicle, when their paths, if multiple vehicles are converging on the same event, it alerts them to when their paths may cross with another responding vehicle, thus preventing an accident. So we also talk about efficiencies, improvement in efficiencies when we're using artificial intelligence. Video analytics software, body-worn cameras are more and more prolific throughout agencies across the United States and across the world. So this also speaks to accelerating investigations. So instead of manually reviewing hundreds and hundreds of hours of surveillance footage, body-worn cameras, the AI can automatically detect whether it's motion events, spoken words, faces, objects, or weapons, license plates, and then flagging those for detectives, saving hundreds and hundreds of investigative hours per case. However, with all of these things, we do have some risks and limitations. Some of those things, as you can see on the screen, we have potential for data bias and discrimination. AI, as I mentioned, is only as good as the data it's trained on. So if historical data reflects disproportional policing in certain neighborhoods, the predictive systems will continue to flag those because it's basing it on historical events. And one case study of this, that there are facial recognition error rates are significantly higher for women and people of color. And this is based on MIT Media Lab studies, NIST lab studies. So, and the key takeaway to that is the biased input equals biased output. We cannot solely rely on the outputs of AI because we have to take in consideration what information it's drawing those conclusions from. The other risk is an over-reliance on these algorithms. Um, Officers may assume that AI outputs are always correct, which we know that they aren't. And one challenge I would put to the crowd is go on to ChatGPT, the free version or the subscribed version, doesn't matter, and ask it to pose an argument as to why the sky is, pick a color, purple, black, orange, whatever. And it will deliver a compelling argument as to why the sky is that particular color. May not be correct, but it will give a compelling argument. And the same thing holds here with the over reliance. So the message to this is that AI should be supporting, not replacing human decision making. It should be helping aggregate large amounts of data to help draw more informed conclusions, but those conclusions and outputs need to be verified by humans and vetted against actual data. There's a lack of transparency or the black box problem. Many AI systems are proprietary. They're very complex. And sometimes even vendors can't fully explain how the model reached a conclusion, which is concerning. This raises accountability issues, certainly. And how do you defend or cross-examine an algorithm in court? And the lack of explainability will certainly undermine trust from both the public and the judiciary. Public trust and legitimacy. So the misuse or errors, in other words, like the wrongful arrest or misidentification, can quickly erode community trust. Communities may see AI tools as surveillance rather than safety measures, and which means that transparency and community engagement are key to avoiding backlash. Some operational risks: false positives waste officer time and resources. False negatives can delay critical response. And the high cost of these technology adoption without proven ROI may strain budgets. All of these things, all of these tools, most of these tools come at a cost, some of them higher than others. And determining whether that cost offsets what the return on that investment will be is something that the agency needs to determine. So I have a couple of case examples. This one is on predictive policing. And I mentioned before the LAPD Pred poll, where it used historical data, crime reports, and this was implemented back in the early 2010s. Now, this software created heat maps of small geographic boxes, which were about 500 by 500 feet square, which predicted theft, burglary, auto crime hotspots. Some of the benefits that were observed during the implementation, there were some short-term successes in prevention. It helped with resource deployment in a city that had limited patrol coverage. It encouraged proactive patrols instead of reactive response. Some of the limitations and risks that came out of this case study was bias reinforcement. Because it relied on past data, there were neighborhoods that had more heavily policed. They continued to be flagged going forward. The transparency issues, getting the information out to the community members, but even the community members and some officers didn't understand how the predictions were generated. And in the end, the program was abandoned. It discontinued it in 2020 or 2021 after the community backlash and questions about its efficacy. And some of the key lessons that they pulled out of this were that predictive analytics can help with efficiency, but not necessarily with equity. The community perception is as much a part as it matters as much, I should say, it matters as much as statistical accuracy. and they need clear oversight, periodic audits to avoid reoccurring biases. And some of the things that they ask, and I pose this to the group, if this was implemented, what could have been done differently, right? Learning from our mistakes, learning from past precedent, how could it be done differently? So certainly some things would be recommendations would be an audit and balance of the data. So instead of only feeding it historical data, they could have incorporated broader data sources, which would reduce the reinforcement of bias enforcement patterns, having more transparency with the public, obviously, human oversight. So human oversight is a key factor, and I think that's actually the next workshop. But keeping humans in the loop. So it should be treated, the prediction should be treated as one input among many, but not as a directive. Independent evaluation. So having external researchers or auditors tasked with evaluating the outcomes. And with this validation, without this third-party validation, it's difficult to prove its effectiveness or to counter the community skepticism. And then obviously clear guardrails on the use, policies being implemented prior to, or policies being established prior to the implementation of a particular tool, because we want to make sure that we limit the use to lower risk applications, like, at least at the onset, like property crimes rather than violent crime enforcement, to avoid controversial outcomes, and testing the model on actual law enforcement data before it's being, so training the models on law enforcement data before it's actually put out into the field. The second case example I have is a facial recognition instance in Detroit. Robert Williams, in a Detroit resident, a Black man, was arrested after a facial recognition system matched him to a blurry store surveillance footage in a crime. He was detained for over 30 hours until investigators came to the conclusion that the AI had made a mistake. And this was, according to my research, it was the first publicly documented wrongful arrest in the U.S. caused by facial recognition. And some of the things that went wrong with this was that the officers relied solely on the artificial intelligence to match without having a human verify it. Unfortunately, as I mentioned before, facial recognition has a higher error rate for persons of color due to the biased training data sets. And there were no policies in place requiring officers to corroborate the findings of AI before they took action. So they relied solely on the output of the AI before making the arrest. And obviously the broader implications for this, the legal risk leading to lawsuits, eroding public trust, policy response to this, the backlash from this, where that several cities like San Francisco, Boston, Oakland, have since banned or restricted police use of facial recognition technologies. There were a number of lessons learned from this incident, establishing clear policy guardrails, meaning human review, accuracy thresholds, oversight, which are essential. Technology must be stress tested across demographics before field use to weed out or identify where the errors may occur. So more human oversight is included. This can be a very facial recognition can be a very powerful investigative tool, but it should never be the sole basis for making an arrest. And it leads us to, and I mentioned several times, keeping humans in the loop. And just to touch on some of these things, because the next session is exactly titled as Humans in the Loop, which we'll get into more detail. But the core message of this is that AI is meant to support decisions, not make the decisions. It's like providing more, aggregating more data that would be virtually, not physically, but physically difficult and challenging, not impossible, but difficult to aggregate all the data and come to a conclusion based on that large corpus. So supporting the tool, think of it as like artificial intelligence, think of it as like a power tool. It makes it faster and easier, but the person operating or holding the tool is responsible for the work. Officers, detectives, leadership all need to verify the output that the AI provides them, and be verified by human judgment before action is taken. Accountability. Courts, oversight boards, and public will always hold humans, not machines, accountable. So these things need to stand up in a court of law, and so they need to be verified and pass measure. So defining clear policies, agencies defining clear policies that AI can provide leads, not directives. Installing safeguard practices requiring a second check from a supervisor or an investigator. And even go as far as to document when AI informed a decision in an investigation, which creates transparency and an accountability trail. Community trust, which is another key aspect to implementing AI. Without this, even the most accurate AI tool can fail. So, but transparency from the agency builds legitimacy. If the communities want to know what the technologies are being used, whether it's drones, whether it's facial recognition, why they want to know what the safeguards are being, what safeguards are being put in place, so privacy is not violated, and other things. Simple communications, whether it's press releases, fact sheets, public meetings, town halls, that can prevent suspicion. Getting out in front of the narrative before it's implemented, having a proactive PR campaign, getting out in front of that, letting people know how this is going to improve the ability of police to protect the citizens and to reduce crime. You have risks of secrecy, the hidden use of AI, like secret surveillance programs. They often backfire when they're discovered, and then there's explanations that need to be had. This leads to lawsuits. It leads to reactive policy changes or bans on using technology now and moving forward, and it leads also to long-term distrust. So being able to implement something later on is a challenge. Oversight models I mentioned before, whether it's civilian oversight boards, advisory panels, third-party audits that can ensure accountability of using this technology. So it's not going beyond the scope or out of the guardrails that are put in place. And the balancing act that requires that the trust requires agencies to balance innovation between the protection of rights, right? We can't sacrifice one by implementing the other. And the acceptance by the public is as important as technical accuracy for sustainable AI adoption. And some cities, for instance, some cities have passed ordinances requiring city council approval for new surveillance or AI tools. And these are things that sometimes the policies lag behind the technology. So getting out in front of them, so it speaks to and informs the policies is the proactive way. Some legal and policy considerations. Privacy protections on the local, state, and national. There are laws that have been in place, like the Illinois Biometric Information Privacy Act in the US to restrict the collection of facial scans without consent. In the EU, the European Union, the General Data Protection Regulation, or the GDPR, sets strict limits on surveillance and data retention. Canada also has regulations on where data is being held. It must be physically held within the confines of the United States. So, within Canada. So the data centers that hold this data on Canadian citizens must be proximately located within the borders of Canada. So if there are outside, like if there are US companies that provide AI tools, that information, that data that it produces, the data that it collects cannot be brought, outside of the confines of Canada by law. Consent and data ownership. So who owns the data collected by AI tools? Is it the vendor that provides it? Is it the agency? Is it the community? Vendors, in some cases, body-worn camera vendors store the video or license plate scans on private servers. I know they're moving away from that because of privacy implications, but this is certainly a consideration. And prior to implementation, policy should define data retention, sharing, and deletion rules very, very clearly before implementing these things. Certain states have different rules, based on their statutes. Agencies in New Jersey may have different statutes to abide by than than agencies in New York or anywhere in the country for that matter. So having your policies reflect what your state mandates is critical. The legal liability of implementing these. So wrongful arrests, detentions caused by faulty AI matches can lead to lawsuits, as I mentioned in the Detroit facial recognition case. The departments will ultimately remain liable for errors, even if it's caused by a vendor's technology. So they assume the risk and they assume the legal risk. And then that increases if there are no human verification safeguards put in place. And I mentioned before, just to reiterate, policy frameworks before deployment. This is essential because agencies should establish written guidelines before adopting AI. There are a myriad of examples out there, IACP, Police One, a number of different organizations and associations out there can help with boilerplate ones, and then they can be adopted to your specific statutes. But these frameworks should, at the minimum, cover purpose, the limits of use, the data handling, accuracy, thresholds, accountability, should address all of these things before implementing. This will ensure officers use AI consistently, they use it ethically, and provides protection in court or public hearings. Police have written policies on most of their actions, most of their operations. These are things that need to be put in place for AI just as much as it is for use of force, gun laws, use of force and gun or deadly force. And moving, I know we only have a couple of minutes before we get to the questions, but I just want to touch on also ethical principles, fairness. We want to make sure that AI tools do not disproportionately harm certain groups. We talked about that inherent bias based on historical data. We want to make sure that is avoided as much as can be as possible, and that requires regular audits of the data so the outcomes can reveal hidden biases. Transparency of the implementation. So the decisions must be explainable to officers, to courts, and the public. Clear communication about how tools work will build legitimacy and trust from the community. Accountability. Ultimately, humans remain responsible for decisions made with AI assistance. So we can't blame it on ChatGPT that it came to a wrong decision. It's ultimately the individual using that tool. This protects both the community trust and officers from over-reliance on technology. Proportionality. We want to make sure we're using AI where the benefits outweigh the risks. And one example of that is deploying predictive policing analytics for burglary patterns, but not for high stakes bail or sentencing decisions, using it judiciously. And ethics this isn't an extra action. It's operational risk management. And so moving forward and just rounding things out, just another slide or two, looking at the future of AI in public safety, I think that it's going to be with the amount of data collection ability, whether it's through drones, CCTV camera, body cams. These are things that are it's going to necessitate the use of AI because of the amount of data that it's going to need to aggregate and analyze. So AI body cams, you see the real-time escalation detection. So using AI as kind of a second set of eyes behind the body-worn camera to determine whether a crowd, whether there's an individual who is a criminal that passes in front of the camera, whether that's they're doing a traffic stop and that individual is immediately recognized as a potential suspect in another crime. Drones and autonomous systems, looking for crowd monitoring, for event monitoring to analyze and identify threats. These things must all have human operators. And then also multimodal AI. I want to jump to the last one. So combining multimodal, meaning using multiple tools in combination. So 911 calls, video, CCTV cameras, and text into one analytical platform. This provides what we call, it puts it under a single pane of glass for investigators and command staff for decision making. It's also taking disparate data, unrelated data, whether it's financial transactions, whether it's license plate readers, reports, CCTV cameras, and taking all of those data sets, placing them, layering them, placing them under one pane of glass where the can be analyzed by artificial intelligence to then start identifying correlations, anomalies, similarities where the link detection or the link analysis can be generated much faster. So just to summarize some of the key takeaways and some of the key core components, AI is a tool. It's not a replacement for human judgment, and it doesn't substitute for human judgment. There are different roles for each type of AI, right? Machine learning, we talked about machine learning, predictive analytics, generative AI. They each have distinct functions and should be used accordingly. And understanding these roles prevents the misuse. It also sets realistic expectations. Do we have the right tool for the right job? Are we going to get the right output from this particular thing that we may be told by a vendor that it may accomplish a certain task? Until it's trained and until it's deployed, we won't know that. Benefits versus risks. So efficiency gains are valuable, but they must be balanced with civil liberty protections, with ethics. Ignoring these risks can undermine operations, community trust, and the ability to implement technologies in the future. I'm hoping that this built a good foundation for, deeper dives into policies and governance and keeping humans in the loop. But I also want to reinforce that the transparency and the ethical adoption is as important as the capability itself, right? Implementing it in a judicious manner, in a responsible manner, is as important as the benefits of that or what it comes out of. So having learned all of this, and I'm going to turn this over to John in just a moment, I have a question for the group to think about, to ponder rhetorically. Where could AI help your agency today? If you look at some of the challenges you may be having, think about some of the tools, it's something to discuss. But some of the things I would encourage participants to do is to have a dialogue with your stakeholders prior to implementation. Engage your IT department, your legal advisors, your risk management, your risk managers, your union reps before you adopt any of these tools to get early buy-in to prevent future resistance. So I'm going to close with that, thanking everyone. I want to thank everyone for your attention and for participating. I'm going to turn it over to John, and hopefully we can answer some of the questions that have been posed by the group.
Thanks so much, Mark. That was
Got it.
really